In this one we have a nice little differential equation going on. So what we'll do is we'll divide both the sides by x square minus 5 whole square, which will give us dy by dx, or rather this will give us this minus 2xy upon x square minus 5 squared. So the reason I did this is so that now this is an exact differential form. So that is it's the derivative of dy upon x square minus 5 by dx, right? Because when this is differentiated, we'll get the derivative dy by dx upon x square minus 5, and when the denominator would be differentiated, we'll get minus 2y upon x square minus 5 squared, minus 1 upon x square minus 5 squared, and then x square would be differentiated to give 2x. So now that will give us dy upon x square minus 5 is dx square. That gives us y upon x square minus 5 equals to c minus x square. And we are given that at x equals to 2, y is equals to 7. We substitute this into this to get 7 upon 5 is c minus 4 equals to minus 7. That gives us c is equals to minus 3. So that gives us y equals to 3 plus x square into 5 minus x square. So the maximum value of this function, maximum value of 5 minus a into 3 plus a is at a equals to 5 minus 3 by 2 equals to 1. So notice that x square can in fact attain the value 1. So the maximum will be at x square equals to 1. So because when x square is replaced by it, we get an inverted downward parabola, a downward parabola. So its maximum is at this point, which is the average of the roots. So the roots for this is minus 3, under root of minus 3 and under root of 5, or rather at x square equals to minus 3 and 5. So the average of them will be 1. So x square equals to 1 gives us the maximum, which is 16. So the answer is 16.